Welcome. This video will provide an overview of VXLAN technology, which stands for Virtual Extensible Local Area Network, and how it's used for creating overlay networks. We'll explore what VXLAN is, why it's needed, its components, packet format, operation, different control plane options, and use cases. So, what exactly is VXLAN? First, it is a Virtual Extensible Local Area Network defined by RFC 7348. It is a Layer 2 overlay technology that operates on top of a Layer 3 network. VXLAN introduces a 24-bit VXLAN network identifier, or VNI, allowing for support of up to 16 million virtual networks. This is a significant increase compared to traditional VLANs. VXLAN uses MAC and UDP encapsulation, which means it encapsulates the original Layer 2 frame within a UDP packet for transport across the Layer 3 network. Now let's discuss the reasons behind the creation and adoption of VXLAN. Traditional VLANs have several limitations. They are limited to 4094 VLANs due to their 12-bit VLAN ID. The spanning tree protocol, which prevents loops in Layer 2 networks, can limit network utilization. Layer 2 domains are constrained by the physical network topology. Traditional VLANs offer poor scalability for multi-tenant environments, and they provide limited mobility for virtual machines across different subnets. VXLAN overcomes these limitations with several benefits. It allows for 16 million virtual networks with its 24-bit VNI. It enables Layer 2 adjacency over Layer 3 networks, facilitating VM mobility across data centers. VXLAN leverages equal-cost multipath routing, or ECMP, for better traffic distribution, and it's ideally suited for multi-tenant cloud environments. Let's explore the key components of a VXLAN architecture. The VXLAN Tunnel Endpoint, or VTP, performs encapsulation and decapsulation of VXLAN packets. It maps traffic between VXLAN and VLAN domains. The VXLAN Network Identifier, or VNI, is a 24-bit segment ID that uniquely identifies VXLAN segments, allowing for up to 16 million virtual networks. The VXLAN header is an 8-byte header added to the original Layer 2 frame during encapsulation. It contains the VNI and reserved fields for future use. The transport network is the underlying IP network that carries VXLAN traffic, which is typically a Layer 3 routed infrastructure and supports multicast, unicast, or hybrid modes for traffic forwarding. Here is the structure of a VXLAN packet. The packet includes an outer Ethernet header, an outer IP header, an outer UDP header, the VXLAN header, and the original Ethernet frame. VXLAN uses UDP as its transport protocol with destination port 4789, which is assigned by the Internet Assigned Numbers Authority. The VXLAN header is 8 bytes long and contains flags, reserved fields, and the 24-bit VNI identifier. It's important to consider the maximum transmission unit. VXLAN adds a 50-byte overhead to the original frames, and so you have to adjust the MTU accordingly. Now let's examine how VXLAN operates. First, Virtual Machine 1 sends a frame to Virtual Machine 2 on the same Layer 2 segment but at a different physical location. The originating VTP VTP1 encapsulates the original frame with a VXLAN header, a UDP header, and an outer IP header. The encapsulated packet then traverses the IP network using standard IP routing. Finally, the destination VTP VTP2 decapsulates the packet and delivers the original frame to Virtual Machine 2. VXLAN offers multiple options for its control plane. The first option is multicast-based VXLAN. This uses IP multicast for VTP discovery and for handling unknown unicast, broadcast, and multicast traffic. Its implementation is simple as defined by RFC 7348, but it requires a multicast-enabled network and has limited scalability. The second option is EVPN-based VXLAN, which uses BGP EVPN for VTP discovery and MAC or IP address advertisement. It is standards-based as defined by RFC 8365, highly scalable, vendor-neutral, and provides efficient handling of broadcast, unknown unicast and multicast traffic, also known as BUM traffic. The third option is controller-based VXLAN, which uses a centralized software-defined networking, or SDN, controller for VTEP management and forwarding decisions. This option offers centralized policy management and advanced traffic engineering, but its implementations are vendor-specific. Let's explore some key use cases for VXLAN. VXLAN is used in data center networking to create scalable multi-tenant environments with network segmentation. It's used in cloud computing for overlay networks in public, private, and hybrid cloud deployments. VXLAN helps with workload mobility by enabling virtual machine and container migration across Layer 3 boundaries. It is also used in network virtualization, decoupling logical networks from the physical infrastructure. To summarize, VXLAN extends Layer 2 networks over a Layer 3 infrastructure. It supports 16 million virtual networks, thanks to the 24-bit VNI. It uses MAC and UDP encapsulation, adding a 50-byte overhead. There are multiple control plane options available, including multicast, EVPN, and controller-based approaches. VXLAN is an industry standard for network virtualization as defined by RFC 7348, and it enables scalable multi-tenant cloud architectures. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.